Hello and welcome to the Chakulabora Speaker Series. My name is Dennis Odhiambo and I am thrilled to be a moderator for this exciting event. Chakulabora in Swahili means healthy food. Healthy food strengthens the human immune system and is the first line of attack against disease. Healthy food begins with healthy soils. The Chakulabora Speaker Series is an initiative of Passion of Hope International to create a forum for policy discussions on triple P-based solutions. That is, people plus planet equals productivity. Our goal is to engage in dialogue on these critical issues with farmers, agricultural students, extensionists, researchers, economists, ecologists, pastoralists, value addition players, policy influencers, and concerned global citizens. Together, we can work towards a sustainable and equitable food system that benefits all. And today, I am delighted to introduce our special guest, Dr. Shem Kuyah. Dr. Kuyah is a senior lecturer at the Jomo Kenyatta University of Agriculture and Technology in Nairobi, Kenya. With over a decade of research, teaching, and working with farmers, he knows how agricultural crops and trees function and how they interact with the environment. His design experiments evaluate the influence of plants on the environment and the effect of the environment on plants. He has keen interest on how agroforestry and forestry systems can help fight climate change, create resilient production systems, and stabilize livelihoods of smallholder farmers. He also has interest in any approach that promises to transform underperforming smallholder farms to productive and profitable systems. Dr. Kuyah is part of a group of scientists that combine empirical studies with research synthesis, systematic reviews, and meta-analysis. He also enjoys teaching ecophysiology, forestry and agroforestry resource management, and basic research methodology. He pioneered the Makueni project, farming in the semi-arid area using retained water membranes. We are honored to have Dr. Kuyah on the hot seat today, and I can't wait to hear more about his insights and experiences. So, Dr. Kuyah, welcome to the Chakulabora Speaker Series. You're the first one. Can you tell us a bit about your experiences from where you were brought up and how you got into the agricultural sector?
Thank you so much. So I'm trained for Jomo Kenyatta. My undergraduate, I trained in biotechnology. Then master's, I trained in plant physiology. And for my doctorate, I trained in plant sciences with a focus on climate change mitigation, where we look at the role of trees in mitigating climate change. But then I switched to looking at the benefits that trees in agricultural landscape provide to people, what we call ecosystem services, and later shifted into options that can help us sustainably intensify agricultural systems. So my interest in agriculture and farming practices dates back when I was a young person. I was raised in the village in Western Kenya. And so my interest was promoted by my grandfather and my grandmother, who are both farmers. So I have a chunk of indigenous knowledge on production systems and on food systems based there. But then also I'm able to merge the indigenous knowledge with the scientific knowledge that I've received during training. So I grew up as a farming boy, herding cattle, feeding on berries during lunch hours from school, as well as producing vegetables for both household consumption and also for sale for our household.
Thank you so much for that. For those who don't know, can you tell us just a little bit about the retained water membrane?
Yeah, so the soil water retention membrane technology that we did in Makueni was an initiative of several institutions, including Swedish University of Agricultural Sciences, SWAT Solutions in the US, and SEAT, Biodiversity Alliance in Kenya. And the idea is to look for a technology that can rebuild the functionality of sandy soils. What we know is that sandy soils have a limitation. They cannot retain water, and also they cannot hold on nutrients. And that affects farmers' capacity to produce, because what happens is farmers get discouraged from irrigation, and also they do not apply fertilizer. And therefore, productivity of sandy soils is low. Now, given the food situation that we have to look for mechanisms that will make all areas productive without expanding the area under agricultural production. So the membrane is designed in a way that it can be able to hold water so that the water does not percolate, and in the process it's able also to hold the nutrient, allowing the water and nutrients to be available for the crop for a longer period. In this technology, there are high-density polyethylene membrane that are installed in a U-shape design. So you have trenches that are dug in the land. The first trench will be, for example, 40. Alternatively, the next trench will be 60, so that the whole land surface is covered by that membrane. And then the membrane then will be able to withhold water and allow production of crops.
So today you'll be talking about push and pull principles in agroecology. Can you just briefly introduce the topic before we start going through the slides?
Yeah, so push-pull is an innovative technology developed by ICIPE. ICIPE is the International Center for Insect Physiology and Ecology. So ICIPE and partners developed this project mainly as a pest control tool. It uses chemicals that are produced by plants to divert insects from a valuable crop away into another crop that is of less value, or that is a trap crop. So the idea is that you have an intercrop that has a crop of value. In this case, it will be cereals, because push-pull in Kenya mainly is based in cereal production system. And then you have a border crop that then attracts the insect. So for this push-pull, you have desmodium, which emits chemicals that pushes the insect, that repels. It's a repellent. And then you have Napier grass or bracharia that is planted on the border, and that is now the trap crop. So what happens is that the desmodium releases chemicals that diverts insects away from the crop, and then now bracharia releases also chemicals that attract those pests. In this case, the insects are the stem borer and also the fall armyworm. Serendipitously, this technology was also found to control striga. Striga is one of the parasitic weeds that can cause up to 100% crop failure, and it's common in cereals. So the desmodium, which is the companion crop of push-pull, is able to control striga. So the technology controls stem borer, controls fall armyworm, and it's also able to control striga. That's what I can say brief about push-pull technology.
Thank you so much. Now I'll just leave it up to you to take us through your slides. I'll be helping you over here. So if you need for me to go to the next slide, just share.
So go to Canada.
Okay.
Thank you so much. So welcome to today's presentation. I have an outline that shows what we will be talking about today, but I also have a list of questions that have dotted the literature on agroecology, because we're looking at push-pull principles in agroecology. there are certain questions in agroecology that remains unanswered. And I strongly believe that understanding push-pull can help us get answers to these questions. For example, one of the questions that farmers are always asking is, will their yields shrink if they engage agroecological practices? Okay. And others are asking, either agroecological practices or agriculture. Is agriculture profitable? And this question has been asked around for a long time. If it's profitable, why are people not going into it? If it is not profitable, what will happen to those who are doing agriculture or agroecology move out? And that then brings us to the elephant question, which is, can agroecology feed the world? Okay? So we have these questions that as we look at push-pull, you want also to think through and see whether we can use push-pull as a template that can help us explain some of the questions that remain unanswered in agroecology. The first thing I thought we need to warm up ourselves is what Dennis has already told us about chakula bora. My first encounter with formally with the chakula bora discussion was with Stella and Isaac in one of our meetings. And then this concept was also later expounded to me more by Brian in one of the meetings also. And it generated an interest in me regarding what I eat. But it also generated another concern about what people eat. And so I set out to find out, what do people say about this chakula bora? What are there? And so what I noted is that there are two outstanding elements of chakula bora, and that has to do with the nutritional value of the food and then also the safety of the food. And that relates to the production systems that we are using, whether the production systems are able to produce the food that has all the nutrients that we need to keep us healthy, and whether we are able to reduce without too much chemicals that can affect our bodies and the environment. But then there is also the reverse, because we're saying, as we discuss about this chakula bora, as we increase our understanding, then we are able to counter the bora chakula concept that dominates our mindset. And so when you ask ourselves what is in our tables in the landscape, we find that we have less nutritious food, and there is a reason behind that. We have unsafe food, meaning because of the production systems, either they are chemicals or the processing system. And in certain situations, we have even no food to eat. So those are the three scenarios that we encounter when you're talking about chakula bora. Less nutritious, either it's not diversified, unsafe food, or no food at all. And no food at all means those situations where there is hunger, either severe hunger or moderate hunger. And so the question is, why should we be concerned? My thinking is we need to be concerned because the culprit of bora chakula still dominates. It still continues. How have we found ourselves in this situation? It's because of monocultures that dominate our landscapes. And the other thing that you need to be worried is I encountered two studies that provide two really conflicting findings. One study finds that poverty is reducing globally, which we need to rejoice. But then another study finds that there is increasing food insecurity. So however much you are running away from poverty, you find that food insecurity is still following you. So depending on what is following after you, then you need to run faster. So that's why I think we need to be worried.
In our country, do you think, or as a continent, can we pivot from what we are producing now using fertilizers to growing organic food and producing the same amount enough for people?
That is the debate. That is the question, and that's one of the questions that was up there. Can agroecology produce enough? Can we produce enough without external inputs? I think in the initial period, no, but over time, yes. Because also there is the fears about agroecology that are related to depressed yields because of the transition. But then as you rebuild soil fertility, and as you optimize the knowledge of production, then it is possible. But then it's not practical for us to say, next year we move into agroecology and we can feed the whole world. Well, we can feed ourselves.
Okay.
Thanks. So here I just thought of trying to remind us how we have found ourselves here. And what we know, those who have walked up outside the city, is that most of agriculture in Kenya has been undermined by monoculture, which is brought about the industrial agriculture. And when you look keenly into the data that we have, you will realize that maize has nowadays successfully eliminated certain cereals. Maize has successfully eliminated sorghum. It has successfully eliminated millets, and it has also eliminated tubers as some of the sources of calories. Actually, maize occupies in Africa closer to 70% of the farms, and on the table, it accounts for over 50% of the calories consumed by humans. And it says now humans are fighting with animals for maize. And so, what is the outcome of this? When we have these monocultures, it means that we have reduced the species diversity. We have a narrow range of species, which now is subject to attacks by pests, but also it affects the diets that we have, because then we are focusing on cereals alone. And you and I know that when people talk about food insecurity in Kenya, they are saying that there is no maize. And that has a problem with the hidden hunger. Because then depending on the farms where we are producing, and that's now the aspect of degradation. Continuous monocropping brings about degradation. And so as we deplete soil nutrients, it means that the crops we are producing do not have sufficient nutrients. So what we are feeding is not providing for us the nutrients that we need. And that brings about that thing called hidden hunger. So that food then, it is not healthy food. But then there is also the other extreme aspect of it, that industrial agriculture is heavily dependent on external inputs. That has two problems. One of the problems is toxicity and pollution. But the other aspect is also vulnerability of smallholder farmers to fluctuations in market prices. So when your farmers, or when our mothers and brothers and sisters who derive livelihoods from farming, when they have to depend on fertilizer or other external inputs, it comes a time when they cannot plant because the prices can hike when they don't have sufficient. But when you are using agroecological practices, then it is possible. You have resilience. You are able to withstand those shocks that are associated by hikes in prices. So I think agroecology helps there in helping our farmers be autonomous. It brings autonomy to our farmers. But also the other culprit that dominates our population is either what we call lack of information on chakula bora or misinformation. You and I know that even a bad idea, when it is properly funded and a lot of noise is made around it, it will even appear to be a good idea. So a lot of misinformation about production systems could be one of the reasons why we are not able to produce healthy food. So that misinformation could be directed about the production system, leaning towards industrial agriculture, or that misinformation may be directed towards the food itself. One of the challenges I always ask myself is, how did we come to a generation where now people can despise millet, can despise sorghum, can despise cassava and potato, and if you have children, you have to force them to eat or to promise them that if they eat, you will buy something better for them. It is because of misinformation that was peddled in those early days. The other aspect that we know for sure industrial agriculture has done is as long as the farming system was changed, what has happened is that we have cleared natural and semi-natural habitats, which used to provide ecosystem services that supported people. For example, even during hunger period, people were able to eat herbs, people were able to eat fruits, people were able to access berries, and that complemented their diets. But now people then have to depend on their pockets. And the challenge with that is that now those who are monetarily poor get so affected, because those who depend on agriculture, then agriculture works as a safety net, in that situation. But then those who really depend on wage, then they are really affected so much. Yeah, so having that background, then the talk then brings us to the push-pull strategy. The push-pull strategy dates back in 1980s in Australia. And during that period, they used repellents and attractants to maneuver the distribution of ball armyworm. At that time, ball armyworm was becoming resistant to pesticides. And so what happens is that since that time, then there's been variations in forms of push-pull that have been tested over the time. And the most dominant one that we have is the maize cereal, which we'll look at later. But on the extreme list, you can see some of the crops that have been tested. And I had explained about push-pull. So you have a crop that can produce chemicals that would repel an insect pest. And then there is a crop that will produce a chemical that would attract the insect pest. And so in so doing, you are able to divert the pest from the valued crop to another trap crop. At this moment, then maybe as a teacher, I like asking questions. What are some of the techniques that we use to divert pests that affect our crops? I'll give you an example that I found very interesting too. One of the challenges in production of cereals in Makueni is birds, so that people don't want to plant sorghum because birds will come and feast on all. But then think of this farmer. The farmer has mulberry trees in lines in the farm and around the farm. And the fruiting of the mulberry tree coincides with the maturity of the sorghum. There is evidence that then the birds will be distracted and they will focus more on the mulberry and allow the farm produce to grow. Another example that some farmers told me, which I found unique, they do plant cassava in maize plantation because they really prefer maize as their food and they're entitled to what they choose as food. But then the moths are really destroying their crop, the maize crop. And because for them the valued crop, according to literature that has been peddled in the country, is maize. So then they use cassava as a trap crop. They plant cassava, the moths will be attracted to cassava, and then it will allow the crop, the maize crop to grow. So those are some of the examples that I would say I've seen, not necessarily as push-pull, but examples of practices that can be easily designed to serve as push-pull principles. So, having that background on push-pull, there are two push-pull systems that are dominant in Africa. One is push-pull that is in East Africa, and this has been designed as an integrated pest management tool in cereal production systems, that is in maize and sorghum. We saw in maize it controls stem borer, it controls fall armyworm and also striker. And so in this kind of push-pull, illustrated by the image there, you have the companion crop called desmodium. And then, and the desmodium is a fodder crop, which means it allows integration of livestock because it produces fodder. And it fixes nitrogen, which means it increases soil fertility, and it is a cover crop, okay? And then you also have napier grass on the border. Napier grass then now is the attractant, the trap crop. Now, this kind of push-pull has evolved over time in response of climate change and other difficulties. For example, at the start, there was silverleaf desmodium, okay, as the companion crop grown inside the field, and there was molasses grass, napier grass, not molasses grass, napier grass. But then there is this problem of spider mites. So and also drought. Then there was a second generation push-pull that ICIPE developed. And in the second generation push-pull, then you have the green leaf desmodium and Bracharia mulato too, which is a fodder. And then now there is a third generation push-pull, and the third generation then employs Bracharia, but the variety is called Xares. So the third generation then, Xares is resistant to spider mites. It's also drought tolerant, and it produces a lot of biomass. So here is the field that I thought I demonstrate to those who have not had first-hand sight of a push-pull farm. I took this picture in a place in Western Kenya. You must come from that place to pronounce that name correctly. So I thought it is that one. That person comes from there. And yes, others will say Emosu Chui. Okay, so one of the things we can pick from this photo is that push-pull can allow for minimum tillage. When you have harvested push-pull, the desmodium, which are those lines, and on the sides it's napier grass, the desmodium will provide cover. Here we had trimmed the desmodium to allow for planting, but it can spread and provide ground cover. So technically speaking, push-pull is a conservation agriculture practice. So all those benefits that we expect from conservation agriculture, we get them from push-pull.
Just a question, and I'm asking this from a point of zero knowledge. Does desmodium grow in all types of soil, or is it just restricted to other types or some types of soil?
Difficult question. I don't have a very exact answer.
Yeah. Can farmers use it in areas that
yes. Okay, I know the answer, but you see, from where I sit as a scientist, there are very different types of soil. So I'm trying to think, is Dennis asking about clay, sand?
Not.
Is Dennis asking about soil fertility? Is Dennis asking about loamy soil, algae soil, you know?
My question will be about soil fertility, because there's some
fertility.
Yes.
So soil fertility, desmodium is a nitrogen-fixing crop. So it should be able to grow in that area with low soil fertility. But then, when soil fertility is very low, it's always good to augment, to enable it to germinate, for it to be able now to grow, develop biomass, fix nitrogen, and improve the soil.
Okay.
Yeah. Okay, then here I'm providing an example of some of the crops that have been tested by ICIPE. These are not all. These are some, because of different reasons. You have seen people use groundnuts as a cover crop, because one of the challenges that agroecology faces is that some of the crops that are called cover crops are not food. And so there is a need to move away from, except if someone has livestock, to integrate cover crops that are food. And so when you look here, you will find that ICIPE has tested groundnuts, whether groundnuts can be able to contribute to the elimination of striga. It has tested crotalaria. Crotalaria, where I was born, has the name of MITO.
Ito.
Yes, that one.
That's a
Yes.
organ.
Bus. Yes, no problem.
Okay.
Yes. So crotalaria, if you check in your palm, you'll find that it is able to handle some weeds. You'll realize that there are no weeds closer to crotalaria. Possibly it has some allelopathic effects. But then you may also realize something, that if it's growing closer to maize, possibly the maize closer to crotalaria might not be as good as the maize that is away. And so those are some of the things that we need to look at from the scientific point of view. It can control weeds, but does it have effect on neighboring crops? Okay. So in the picture we find that Desmodium really controls weeds, eliminates. Crotalaria does suppress striga, and groundnuts is really not that effective. Okay, in South Africa, so I would say most of my interaction with the pushpull is in Kenya and in East Africa and not in South Africa. But in South Africa, what has happened mainly is the use of pushpull as part of a wider integrated pest management strategy in sugarcane farms against sugarcane stem borer, against the sugarcane stem borer. And here the components are molasses grass. I put an example of molasses grass and the push. So the push component is the molasses plant, and the pull component is the BT maize, and this siege. This besiges, is it called fidges? Besige. Sages, or yeah, those ones. One of the things I like about molasses plant is its capacity to repel ticks. There's a time I was doing some kind of dairy farming, and a friend advised me to plant around the grazing area, and for sure molasses plant does repel ticks in addition to the other aspects. So in this system, molasses plant then repels stem borer, but also the other good aspect of pushpull is its capacity to attract natural enemies. Natural enemies are enemies of the pest. So that by the practice attracting insects that feed on the eggs of the pest or on the pest direct, you help reduce harmful insects without using chemicals. So it's a really strong component of biological control. So here we'll go very quick. I want just to show you the link, how push-pull then can be able to link between agroecology, how push-pull fits in agroecology. And the first one is diversity. And and that image shows the 10 elements of agroecology. FAO went into great details to try to define what entails agroecology. And so when you go through, I won't go through all the 10. I'll go through around 6, but still push-pull fits well in all the 10 elements of agroecology. Now, diversity. Remember, if we want chakula bora, we have to diversify our diets so that we avoid the idea of a narrow cereal-based carbohydrates diet. So it enhances ecosystem services and it diversifies diet. The other one will be about co-creation and knowledge. One of the things that I always feel is indigenous, traditional, and local knowledge that we are not tapping from generation to generation. And one of the ways that you can do to change our people is change their culture. And an easier way of changing our culture is through food. Earlier on, I mentioned about my grandmother. So I ever saw hand in hand about milling grain. And during that time, information is passed from generation to generation. We used to go and collect mushroom. And during that time, knowledge is passed from generation to generation. We used to make traditional salt, leaf, and you are told about its medicinal value and other things. So you find that agroecological practices like push-pull, they allow that process. What we are doing in push-pull is we are not trying to reach to farmers in a participatory manner to ask them what will they want integrated in push-pull. And in so doing, we are able to tap on traditional knowledge. We are able to tap on the knowledge they have about pest management and blend it up with the scientific knowledge you have about that pest management so that we would bring out something that is acceptable to the farmer but meets the needs of the day. The other aspect is synergies. What we realize is that push-pull harnesses biological synergies to enhance ecosystem services. An example is just biological nitrogen fixation. It's really an important function that it synergies the functions, the benefits of push-pull, so that you have desmodium that fixes nitrogen. It's a legume for the maize or the other cereal that is not able to fix nitrogen. Now, think of efficiency. To me, efficiency in push-pull comes when we are able to produce less without much external inputs. And so this reduces the cost, but brings about what I've explained about autonomy, the capacity to make the farmer not vulnerable to fluctuations in market prices, especially for chemicals. Next. Now, there's this aspect of recycling, which is key to agroecology. And in push-pull, what we see is the fodder crop feeds the animal, and the animal provides manure that nourishes the plants, so that it's a closed cycle, and you recycle the organic matter into the system. And then resilience, that capacity to bounce back, to recover from shock, okay? You realize that push-pull farms, they would resist attacks from these pests. Yeah, so that is next. That's about the benefits of push-pull technology. And here what we want to underscore is the fact that push-pull benefits are derived from diversification of the production system and also the use of non-toxic chemicals. And so this means that it's environmentally friendly, but it's also one of the most appropriate tools that can be used to increase productivity of complex systems like small-scale farmers, where a farmer has to produce the wood they need to cook, the food they need to eat, the fodder they need for their animals, and also rebuild soil fertility during the same period. So these are some of the benefits that by interacting with the farmers we have seen with our eyes, and farmers have told us. The most key, and this also resonates with my heart, is that there's need to improve productivity of the system, and there's also need to increase income from fodder, income from sale of surplus, and income from milk products. So this is our last slide, and I borrow some knowledge that we have from upscaling the benefits of push-pull technology for sustainable intensification of agricultural systems in East Africa. And so one of the things that I would like to inform us is that push-pull is already an intensified system. It has at minimum 3 crops. You have the napier, you have the desmodium, and then you have the cereal. But then some of the discussions that we have had with the stakeholders is that the desmodium, for example, is not edible. And so for farmers who do not have livestock, how can they benefit? Okay? So what are the opportunities that exist in your areas? Because where we have worked, some of the opportunities that we have seen is integration of legumes in push-pull systems. So for someone who would have said that I cannot eat desmodium, and the maize would be a narrow diet, then we can introduce legumes, which will diversify the diet and improve the nutritional content of the food. Now, there is this other element of productivity. Can agroecology improve incomes? Is it viable? Is agriculture viable? And so one of the aspects is introductions of high-value crops. Okay? One is because of their short duration period, and the other one is because of the demand. And so there are experiments with ISIPE looking at integration of vegetables, and those are both indigenous and exotic into push-pull systems. Agroforestry is always at my heart. And so we are also trying to look what will happen if you shift this push-pull system in a smallholder system that is dominated by trees. Would the new environment compromise the capacity of push-pull to control pests? Because, as we have said, farms are small, and the farmer wants everything within that farm. And so we cannot have a situation where we are cutting a chunk of a farmer's piece and saying, we will implement push-pull here. We are looking at a situation where we adapt push-pull to existing farming system. And so at last, what we are looking at is how agroforestry can be integrated in push-pull. So on brief, one of the questions that I would ask us is, what are some of the options for expanding push-pull into other cropping systems and farming systems? From where you sit, either as a farmer or even just as an eater, you have to know how it was produced. What options do you see that exist for helping us produce healthy food? Yeah, and lastly, when we are talking about upscale, we normally acknowledge the consortium. We are a consortium of 18 institutions, and you are funded by the European Union. Thank you so much, Dennis, for this opportunity.
Thank you so much, Dr. Kuyah. That was a very enlightening presentation for me personally. I believe everyone else here shares the same sentiment. And we'll give Dr. Kuyah a round of applause. Thank you. So, welcome back to the Q&A session. I'll pick some questions that you asked, and Dr. Kuyah will try to answer as many as possible. The rest will be sent to your emails. So first question, Dr. Kuyah. How accessible is desmodium to smallholder farmers?
Desmodium is it's available in shops, especially within Nairobi, in seed companies. A caveat is that it's slightly expensive at the moment, but there are initiatives that are looking at seed production for desmodium with an aim of lowering the cost and increasing accessibility, availability at smallholder farmers.
Okay. Second question. I think I'll merge two questions here, which seem similar. Are there particular legumes that can be used in push and pull technology?
So the current integration of legumes has considered cowpea, beans. At Jomo Kenyatta University of Agriculture and Technology, we have considered pigeon pea. So what we are doing is evaluating the effectiveness of push-pull that has been intensified with this legume as a pest control tool. We need to see, once you introduce this legume, does it sustain the pest control ability or it loses them?
Is push-pull enough to manage pests, or can you integrate with other ecologically sustainable pest management approaches?
A good question. Push-pull is part of integrated pest management strategy. Yeah.
Will the integration of other legumes have the same effect?
That's what we are waiting.
All right. I see farmers growing potatoes in between or next to maize crops. Is it one of the push and pull ecological methods?
I think one of the strategy for planting potatoes is as a cover crop, which provides the benefits of suppression of weeds.
Okay.
It also has other benefits. I'm not it has not been tried as one of the crops to be used for push-pull.
Has push-pull been tested with sorghum and or millet?
Yes, it has been tested with sorghum, found to reduce striga in sorghum and also stem borer in sorghum.
Okay, and there seems to be a lot of interest around the water retention membrane. People want you to elaborate on the dimensions of the membranes. What units do you use? What is the purpose of the two membranes?
Yeah. So the dimension of the membrane are designed after testing capillary of the sandy soil. And so what we used was a 28 centimeter membrane in length, and the depth is 40, the other depth is 60. The idea is that once you fold that membrane into a U shape, it has sufficient depth to withhold adequate water. Now, the purpose for the two alternating depth is to allow for overflow of water, but then when there is overflow, the water does not just disappear into the sandy soil, but the water from the 40 then can go into the 60, which will hold a larger volume. And then when there is excess, then it can now overflow to reduce flooding or waterlogging, not flooding, waterlogging.
Okay, the last questions. Are the chemicals released by Desmodium the same used for scientific research? Was it used or needed?
Possibly the questioner is asking whether there is need for more scientific research and whether the chemicals produced by the two different Desmodium species are the same. Need for more research? I'm not sure about that.
Okay.
Yeah, I'm not sure about the question.
Last question, last question, and I'm not sure if this is your area or not, but someone is asking, can you talk about rabbit urine as a pesticide?
Definitely not my area.
Okay, so thank you very much. On that note, we will end this session. I would like to remind you that all humanity has a right to healthy and culturally appropriate food produced through ecologically sustainable methods. We all have a right to define and influence our food and agricultural systems. This is the principle behind the regenerative agriculture movement that Passion of Hope International stands behind. So thank you very much for attending this first session of the Chakulabora Speaker Series. We hope to see you for the next one, and give yourselves a round of applause as we close out. Capital.